So, first of all, I record my sincere gratitude to the organizers and the director of ICAR-NIANP and my parent organization for giving me the opportunity to stand before you. So, the topic of presentation is next generation tools for animal welfare monitoring, the synergy of infrared thermography and artificial intelligence. So we have been discussing about the use of animals for experiment. Of course, my predecessors, they have talked about the use of laboratory animals for experiments and for food production. So here the main theme of another theme of the conference is to how well we can take care of welfare of the animals. So the foundations of animal welfare comprises of 5 freedom, as you know very well, that freedom from hunger, pain, and also freedom to express. So the recent 5 domains of the model is consisting of nutrition, environment, health, and behavior, and mental state. So these are the recent concept which covers how a welfare of the animal to be taken care. And it doesn't mean that animal, when they are into comfort situation, they should also be given a freedom or opportunity to express their positive experiences. So this is one of the important area. So having said how well we can monitor the animal behavior, whether it is including laboratory animal or experiment animal or the farm animals or wild or zoo animals, laboratory animals. So the major area which covers about the behavior recognition, second is vocalization analysis and physiological signals. So coming to the animal welfare monitoring tools, if you see the keeping the animal welfare, that's the core concept encompassing the health and behavior. So the basic methods, that is the traditional on-site assessment. Generally we go to the farm and watch the individual animal and we see that whether they are comfort or not. Next comes the advanced method, that is recently what we use, the technology enabled monitoring, that's precision technology tools, sensors and devices. Next comes algorithm methods, where the artificial intelligence going to come into role, that is data analysis and prediction, how well we can predict the abnormal behavior or how well we can give alarm to the particular condition. Next comes to the highest level of integrated system, when we integrate one or other model to monitor the animal welfare. So categorization of welfare monitoring methods, if you see, so there is direct behavioral observation, as I told, there is ethogram, that is monitoring the animal behavior, and metrics, that is how much time it's spending for each activity, we call it as metrics, and abnormal behavior, and cage side monitoring for laboratory animals. And for wild animals, we go for specific species specific or wild animals condition specific monitoring to observe their behavior. Coming to the physical and health indicators, physical and health indicators, as you know, the body condition scoring, lameness scoring, and injury, code condition, clinical signs, and disease monitoring. Then animal based indicator, they are all very specific to particular species or particular animal, where we do animals based indicators. And physiological, biochemical, of course all of us know, we use the sampling methods, blood and hair, milk, non-invasive method of sampling collection for estimation of stress related hormones and other stress indicators. And for wild animal stress monitoring, generally they go for fecal glucocorticoid metabolites to monitor the chronic stress in case of wild and captive animals, particularly reptiles and all other breed. And in addition to that, we go for monitoring the vitals like respiration rate, heart rate, pulse rate, and ultimately the most important thing is the temperature, which I will be discussing later. So research and environment measures, how the housing conditions, spacing and other provisions are there, and quality feed and water, and how they are accessible 24 hours or whatever the time interval. Stocking density is one of the important criteria, where it causes a huge stress among the animal, and the environmental condition where the animals are maintained. And composite welfare assessment, now recently they have come out with the welfare quality, that is the trademark given by the welfare quality network. They have given a certain guidelines how an animal to be assessed for whether welfare comfort is there or not for farm animals, and risk based, as I told, and species specific protocol for the zoo animals. So coming to the next generation tool. So having said about this, of course, the conventional method, whatever we have discussed. So now how the integrated system of the next generation tool like sensors and devices can be employed to monitor the animal behavior, their health condition, everything. So coming to the there are two components, that is wearable sensors and basic camera. So here these wearable sensors comprises of many sensors and devices which are all of invasive nature, non-invasive nature or semi-invasive nature, and they are employed into the animals and they are collected data. But here there is no much integration directly one to, suppose temperature means I will get only temperature data. If I want pulse or rumination rate, only that much I will get. There is no much integration. And basic cameras, as we know, the surveillance camera which are installed in the farm condition just to note down the movement of the animals and their behavior, whether they are present or not. This is the normal thing where there is no much integration. So when the artificial intelligence model like machine learning, deep learning, these models, when they are integrated with the existing devices and sensors, then they become the highest system for prediction and giving alarm. So the smart houses, they integrate high-tech sensors, the entire housing system is getting monitored. For example, for laboratory animal, they have come out with the house cage monitoring system. So the totally 24/7 sensors are installed for the laboratory animal cages, where you will get continuously updating real-time information. Next, the smart rack, that is for again laboratory animal. So these are certain example. And coming to the automated monitoring system, where they completely automatically integrated with the deep learning models, where they process the data and give the interpretation immediately. For example, in our traffic signal, we can observe the recently in Bengaluru, many signals are integrated with the computer-based vision technology. And these are the certain examples where you can see the so the neck collar sensor and pedometers and collar sensors and heat detection sensors, and down there it is rumination sensor, and the video camera is getting installed for the farm, and tail movement sensors are available. And recently they have come out with the robotic monitoring of the feeding system in the farm. So coming to the automated system or smart house is where the integration of devices and monitors and real-time data is getting flowed, and the bioacoustic area, observing the acoustic sound raised by the individual animal during particular time using the microphone installed in the collar sensor devices, where with that they can predict the behavioral aspect. So coming to the computer vision, video analytics, where machine learning, the normal RGB camera can predict, and coming to the infrared camera, where they can use it deep learning method to predict. As I told, wearable sensors, they mainly use accelerometers and GPS system and biometric acoustic sensors, bioacoustic sources. So coming to these are all the commonly available system, but nothing from India. So this is all from abroad. If at all we want to have, we have to import, and there is a lot of restriction. And even if you want to use, they are not suitable. First, we need to validate with our animal. That is the status where we are standing now. So these are the different sensors for animals. So coming, you can monitor again. So for a cow, almost at every part of the body. So we can fix sensors to monitor their 24/7. Their activity. So this is how the things are involved, and in addition to that, we can go for monitoring the health and behavior, physiological status by observing the milk and feeding system and automating gating, and through inline milk sensors are available, where complete metabolic status of the animal we can get through the milk. This are the side, the table depicts about the different company, those who have come out with the different sensors and these systems for mainly ruminant sheep and goats. So coming to the our study, where we have done video analytics of calving behavior, this first kind of study in Murrah Buffalo, almost about 4 days before calving, 4 days after calving, continuously 24/7 we recorded, and we extracted the information to my PhD students. So it was totally time consuming. So the recording was almost for 1 week. Sorry, maybe. So thank you, sir. So recording we did, and later we extracted the information that was time consuming. So this is the information we got, and interestingly we could find many such behavior which is of predictive of calving. So what is the alternative to go for this video? There comes your artificial intelligence. This is the artificial intelligence. As you know, it is the simulation of human intelligence where the machine is fed with the data. So thereby we extract the information. So this is, there are different domain, that is machine learning. There are the different wings, they come under the artificial intelligence. Machine learning, deep learning, depends on the data and output. So you are going to apply machine learning or deep learning tools. So in the NLP, language processing, that all we use ChatGPT, everything is there, generative AI we call. So among these, the computer vision is the one of the most applicable thing for animal science particularly, where you can use for body condition scoring. One of our PhD student at our SRS, we have come out with body condition scoring by using mobile based system. We have developed a model, and locomotion defect, currently 2 of our PhD students are working based on the computer vision and locomotive detection for lameness prediction, how well we can predict, and metabolic stress, of course we are not working currently. And animal identification, so the muscle based identification, facial recognition, many things have come up recently. At NDRA Karnal, people have started working. Behavior identification, as I told now, and general health monitoring. So this is how the computer vision, where the image we acquire, that process acquiring of images, and image is getting processed, that image is getting processed when we go for image enhancement or augmentation or image improvement we do. Then later we go for image feature extraction. Actually in that image what I want exactly, that is the more important thing, that is called feature extraction. After feature extraction we go for developing a suitable model and get the suitable predictions. So this is how different how the particular image is getting annotated. So this is box bounding box annotation, keyboard annotation, this is our Dioni cattle at SRS Bengaluru, and this is segmentation and skeletal. This is how skeletal, this is depends on the need what you want to know. So because if you want to know whether the animal is grazing or not, so you have to go for skeletal annotation. So these are all the different approaches we have started. Lion, and this is again a bit mask bit mask annotation. So this is how the image is getting processed. Once you code the image, and automatically you can monitor for the any type of behavior, their movement, first particularly for stress detection, and we can make a decision on spot. So we call it as a cloud computing. Cloud computing is the recent one, and edge computing is on-spot decision making. Cloud computing is just like our phone pay. Once you transfer money, it goes to cloud, from server it comes back. But here edge computing, the decision is taken on-spot based on the real-time update of the images. This is how it works. And recently one of my PhD student is working on computer vision to monitor the calving behavior, to come out with a mobile based tool. So where 24/7 calving behavior will be monitored based on certain selected class, we will be able to predict the calving. And before that Nikon camera, AI camera, they have already come out with the tool, that is NILIMO, Nikon live motion detection for calving prediction. So these are all the another algorithmic recent model, where they have recently predicted based on the temperature profile in the wild forest condition, the fly movement they have identified, because that fly, it is re-emerging threat in US recently now, and they are predicting for the fawning season in the deer, which may cause a huge welfare concern. So coming to, sir, 1 minute more. So coming to the main, the temperature, as I have told about many sensors and devices. So what is the alternative which is cheaply can be monitored using the thermography? That is, by monitoring the temperature, we can identify the animal's stress condition or the physiological status. This is about the thermal imaging, where infrared thermography can be used. And this is William Herschel. He was the pioneer in discovering this infrared radiation. So infrared radiation, generally it falls between 8 to 12 micrometer. So it falls beyond red. It is not visible to our eyes. That's why it is called infrared, beyond red color. Red color is the last visible spectrum for our eyes. So this is coming, this is of course infrared thermography is applicable in almost every field now, and this is the medical imaging where we are applying, and these are the infrared imaging cameras which is available. Mobile based cameras also have come up, and this is the conditions how we have to take the infrared imaging. And this is the main advantage of infrared thermal imaging. It depends on the pixel size. You can measure thousands of temperature spots in a particular image. That is the main advantage. You can very well appreciate. So this is again the huge number of applications, of thousands of publications are coming up recently on the application of thermography in veterinary medicine. These are the different area. And this is of course starting from human medicine. Almost 50 years back in human medicine they started. Now it has come into almost all into veterinary field, the hoof health, udder health, thermal stress monitoring, everything. And these are the different disease condition for each animal, we can use it. And the FMD monitoring and foot and mouth, this is what we have done under field condition, how well we can predict. And blue tongue, and for particularly wild animals, the rabies virus, and USDA has recently published how that can be detected before well the symptoms can appear based on the temperature alone. This is again mastitis what we have done, and hoof health monitoring we have done through our thesis work. And another, this is interesting area, the first of kind work where we have published by using the temperature profile alone, how well we can predict in the time of calving. So that we got very interesting publications. And this is about another important welfare concern. Sir was talking about the calf welfare in the morning session. So the neonatal thermogenesis and the neonatal thermal adaptation is very important area where we can use thermal imaging for monitoring. And of course this is the thermogram of equine, and this is for different disease and stress conditions, and not only limited to large animal, in small animal it has got a huge application. In Western country it has become one of the diagnostic tool for monitoring. Of course, as I told you, every field, not limited to pet animals, coming to zoo animals to monitor their health, their movement, and their thermoregulatory mechanism, everything can be possible through thermal imaging. So coming to ART, how it is well integrated. Now the IBM company and NVIDIA, they are all working out the thermal facial picture. It will be a future for our individual identification. So the big team is working on to this area. This is again, and this medical imaging, one of the important area where we work on the integration of the images. This is the automated thermal image is placed where once the calf enters to the feeding bin, and automatically temperature is captured and regularly it is getting updated. Another Swedish company, they have come out with the CADI mastitis AgriCam, where it automatically scans the udder. So whenever it comes for milking, and it sends the thermal images, and it gives the alarm based on the udder thermogram images, udder temperature. So this is about wound healing monitoring in clinical application surgery, and how based on the temperature profile. And recently people have come out with a smartphone based thermal imaging temperature sensor. From the distance you can monitor at any time, immediately will get it. Yeah. So that's the final slide. And where we are, of course, in Western country, they have gone so much of ahead beyond our imagination. So they formed a Society of Thermology, American College of Clinical Thermology, European College of Thermology, and they get a certified course for infrared thermal imaging. You can see the visiting card of a doctor, that is, he is a certified clinical thermographic associate, where they employ for breast cancer screening. Now in India also it has come, thermal imaging for breast cancer screening. So thank you so much for your kind attention. So briefly I could share my knowledge. Yeah. Yeah. Thank you all.